Okay, in this video we're going to be looking at literal equations, and what this is solving for a variable, but there's usually more than one variable in the equation. So the big key here is you can solve for any variable, and the key also is to remember that letters variables are treated the exact same way numbers. They're numbers, we just don't know what they are yet. So all the operations that we do with numbers, we still do with a letter. So again, we want to identify what we're solving for and then try to isolate it. So that's the key here. So let's take a look at an example right here. What if area equals length times width? So here we have three variables. We have A for area, L for length, and W for width. And obviously these change, depending on the shape and so forth. So let's say we want to solve for A. What's the area? Well, that was given to us. So let's go ahead and put that in. Area equals length times width. Okay. Now, let's go ahead and say, okay, what if we want to solve for the length? Get the length by itself. So what we want to do is look at this problem right here, identify where the L is, and get that by itself. So we have to undo anything that's on that side of it. So here, what's with L? A W. So I'm going to move the W to the other side. So we have L times W. How do you undo multiplication? You divide. So just like you would move a number, you move the letter the same way. So now we have A over W equals L. And then we can, write that over here. So A over W equals L. And we see that there. Now let's go ahead and solve for W. So I'm going to start with the original equation of A equals length times W. And we do the same thing. I want to solve for W. So W is right here. And I want to get W by itself. So I'm going to undo that L by dividing it out. It's multiplied. How do you undo multiplication? You divide. So you're undoing the operation. So W equals A over L. We can see that right there. The L's cancel. W equals A over L. So that is what we're doing. So notice we can write the equation three different ways. Okay, and all depend on which one we want to get solved for. All right, so let's take a look here at a couple other examples. So now this is an equation for perimeter. Perimeter equals twice the length plus twice the width. So we have three variables. Okay, so let's say we want to solve for, let's say here, W. So what I like to do is highlight the W, figure out what we're solving. So here, to get the W by itself, we have to move this and we have to move this. I'm going to move this one first. So that is being added, so I need to subtract 2L from both sides. Okay. Now notice, P and 2L are unlike terms. They're different letters, so I can't combine them. So I'm going to write P minus 2L is equal to 2W. Okay. And again, I am still trying to get this W by itself. So the last thing I need to do here is get rid of that 2. That's being multiplied, so I'm going to divide by 2, both sides. And there it is right there. Notice that's gone. And then, if I just write it off to the side here, W is equal to, and you can really just write that. We'll talk later about, different ways to write that. The one thing you don't want to do is you can't cancel these 2's because you have to cancel a 2 from this term, and this term. So this is already reduced, so we're going to leave the answer just like that. Another great example down here is distance equals rate times time. So D equals R times D. Let's solve for R. So R is right there. So I want to get R by itself. So the T is in the way. So I'm going to divide by T, undo the multiplication, and there you go. R is equal to T divided by T. Okay. So there's examples where not every equation has just numbers in one variable. A lot of times we have multiple unknowns or multiple variables, and we need to isolate a variable. So that's what solving does. All right, now the most common examples that we'll see early on is solving for y, because we do this for like graphing lines that we'll get to in the future. So to solve for y here, we want to get y by itself. So solve for y. So I'm going to first highlight all the y's in the problem so we can see exactly what we want to get by itself. Okay, so now let's go through and identify, okay, what has to be moved. So I identified there's the equal sign. I need to move the 3x over, and that should be it. So I'm going to move the 3x over to the other side by subtracting. Now the big key thing here is, okay, can we combine a 5 and the 3x? No, because that has x's and that doesn't. So we got to put them separate. So I like to put the x's first. That's pretty standard. and we follow it up like that. Okay, so put the x term first, and then the -5 goes behind it. Notice those cancel each other out, so 3x minus 3x, that's gone, so y is equal to that. So you know you're done when y is the only thing left. Take a look at the next example. Okay, so I want to move the 2x, move that over, and I want to move the 3 over. So let's see how we do that. This is being added, so I'm going to subtract 2x from both sides. Again, I cannot combine 12 and 2x, so I'm going to put -2x plus 12 as separate terms. And then you bring that whole thing down, 3y. Now the next thing is we have to undo that 3. So divide by 3. Now the key is to divide everything by 3. Okay. Now you could show it like that, or you could show it like this. A lot of times people want to do this and divide each piece by 3. As long as you do it to everything, that's fine. And we'll see this the most often. So a lot of times we'll see that written as -2x over 3, like that. And then what's 12 divided by 3? When you separate it, you got to reduce it. So we're going to go like that. So really there's, this is acceptable. We could say that, this is acceptable too. Now if you do break it up, we should reduce that. So either one of those answers will work. Most likely, we're going to want to see that eventually. Okay, so I'll get used to doing that. So let's take a look at this next example. Okay, now notice there's nothing over here. So the y is the only thing left. So one easy thing to do is notice how this is -y. So watch this as a shortcut. Now we could move the 26 over and the x over and then divide by -1. Now that's 3 steps. But if I add y to both sides, we have x is plus 26, the only thing left because those cancel, equals y. And the question is y by itself? Did we isolate it? Yes, we did, so we solve for y. Even though y is on the right-hand side, it doesn't matter what side it's on. You're just going to have 2 separate sides. So y is equal to x plus 26. So that one is done. All right, so let's take a look at this last example here. So here, what I'm going to do is I'm going to do it the other way. I'm going to say, okay, let's leave the y over here. I'm going to move the x to the other side. So I'm going to subtract x from both sides. So I have -x plus 10. Notice I can't combine them. And then we still have this negative in front of y. So how do we undo that negative? Simply divide by -1. And I'm going to do it to each term. Okay, so now when I divide by negative, I'm just going to write it off over here. Y is equal to, okay, negative divided by negative is a positive x. And then 10 divided by -1 is -10. Okay, and that's it right there. So notice, even though the y is on the right hand side, we still have isolated it, and I'm going to highlight those again so we know we're done. So that's a great example of what we're doing there. Okay, so here we have a couple problems up here. Notice we have 3 variables, and down here we have 2 variables, and I want you to solve for y here, for b here, and for a here. And again, I want you to try these. So after the conclusion of this video, go through these, and this will be your first round of practice.